Greeting Mathematics N6 students, welcome again. As I have promised, in this session I'm going to be doing second order differentiation, but for now I'm going to finish off or show you how you are supposed to calculate this one. I hope that you did take your time and try to resolve it, because if you did not take your time, it will be useless for you to just watch. Mathematics is like, for example, when you are watching a movie. You know, if you are watching Van Damme doing his things there, his spin kick, you can think after the move you can do this. But if you have never practiced it, you will not be able to do them. So that's why it's important for you to go and do it home. So that you will understand, you will see where you're making mistakes, okay? And obviously you can improve from there. Now let us look at this one that I gave you before. This is still a first order, okay? So the first thing that it's saying, make sure that dy over dx and y are on the same side. We can see here they are not on the same side. So let us bring them to be on one side. So we are going to have dy over dx. To take this to the other side, we are going to change the sign. It's going to be plus. Then I'm going to write by putting cot x first rather than y, so that I can easily identify my y coefficient. Remember, we did that with the previous one. So this is multiplied by 1, which is going to equal to the last one, which is tan x. Okay? Once we get to this one now, say the next part, we need to make dy over dx, the coefficient of it, to be 1. Now, in this instance, it's already 1. So we don't have to do that, because already if there's no number here, it means it's 1. So we are sorted. We need to go to the next one. Make the coefficient of y to be p. So we are going to say now, let p equal to cot x, obviously, which is positive in this instance, not like the previous one where it was negative. Then we have the integral of p dx that we want to calculate. So we want to calculate this now, the integration. So integral of cot x dx. I have mentioned in the previous lesson that you need to know where to find stuff in your formula sheet, okay? So you need to look for the integral now of cot x in your formula sheet. So you'll go to your formula sheet, you'll see page 1, it's not there because it's trigonometry. Then you go to page 2. You will see at the bottom, it's a third one at the bottom, the integral of cot ax. But our a in this instance is 1. Okay? The answer is the last column, remember, because we are integrating. So in this instance, we are going to have 1 divided by 1, which we know is equal to 1. It says then it's supposed to be ln of sine ax, so it's going to be sine. Our a in this particular instance is 1, so we are not having to write 1, so we can just put x, okay? And then it say plus c, but we don't put plus c yet, okay? So let me just simplify it for you. So 1 divided by 1, we all know is equal to 1. So the integral of cot x dx is going to be ln of sine x, okay? Then it say, take whatever that does not have dy over dx and y, which is obviously on your right-hand side, make it to be q. So our q in this particular instance is tan x, okay? So we have our q now. Remember the formula, which is found in page 7. It says y times e to the exponent of integral p dx is equal to the integral of q times e to the exponent integral of p dx dx, okay? Now we need to substitute whatever that we have found. So we do have the integral of p dx, we can substitute that. So we have y times e, the integral of p dx, we have found it to be ln of sine x, which is going to equal to the integral. The integral, we have q, so we need to substitute the value of q. We have it here, okay? We have, which is tan x, okay? Multiplied by e to the exponent, integral of p dx. We have calculated that to be ln sine x, okay? all dx. Now, obviously, you hope you remember last time, we apply one of the exponential laws. So the exponential law that we applied was that we can take this f at x and bring it down since the e and the ln has the same base. So what we are having y multiplied by sine x, which is equal to the integral of tan x multiplied by sine x dx. Okay? You can see now, this is the part that we need to integrate. You can check, obviously you are going to check your inspection. Can I integrate this using my inspection? And you don't have the inspection which has tan x and sine x. The next one that you can check, we are checking, can I integrate this by using function and its derivative? In this particular instance, you don't have a function and its derivative. So that's why your trigonometry and knowledge of trigonometry, which you learn in N4, comes into play, okay? Which is not part of N6, but you need to know from your N4. So we can say here, sine tan x, we know it's equal to sine x divided by cos x, okay? Then we have this sine x, which we have brought down here, dx. Then we can multiply, easy, okay? So you are going to have the integral now of sine squared x divided by cos x dx, okay? All of this is equal to y times sine x. Now here, this is not the derivative of the denominator as well. But we know from trigonometry, okay? We know from trigonometry that sine squared x, also we deal with it in the formula sheet on the last session, sine squared is equal to 1 minus cos squared x. Okay, that's what we know. So we are going to use that knowledge because we know. So we are going to have y times sine x integral. So instead of writing now sine squared x, we are going to write 1 minus cos squared x. All of this is divided by cos x. Happy? Think now, it's much easier. You can see we need to separate, okay, this. So we are going to separate the term that we are having because the numerator, this one is also divided by cos x. This cos squared x is also divided by cos x. So we need to separate, okay? So we are going to have y multiplied by sine x, which is equal to the integral of 1 divided by cos x minus cos squared x all divided by cos x dx. Okay? Then your trigonometry again will click in. Okay? So to say that this therefore is equal to sec, so therefore we are going to have the integral of sec x minus this will divide, so we'll be left with cos x there, dx. Then we have y multiplied by sine x, okay? So that's what we are having at the moment. So now we are having that y times sine x, which is equal to the integral of sec x, which we can be able to calculate now. So this is y multiplied by sine x, which is equal to the integral of sec is also found on page 2, okay? It's going, our a value in this instance is 1, so we don't need to bother by that one. So we are going to say it's ln, open brackets, then we have sec ax, our a is 1, so we are going to be left with x there. Then we have also tan ax, so we have tan, our a is 1, so we can put x there, okay? Then we have finished with this term. Now we need to go and integrate this other term. So also it is found on the same page, on page 2. It says that it's going to be equal, we have a minus here, so we still have a minus. It will be sine ax, our a in this instance is 1, so it will be only sine x plus the c, okay? So this is our general solution which was needed, okay? More of these, you can do them at your own time, okay? There is more of these questions that you can practice. so that you know. These are taken from the past papers, so you're supposed to be able to do them. There is none of them that has an error. So don't say that you have a problem with the error. Okay? So now we are going to move into the other one, which is a second order. So now let us look at the second order. Okay? Your second order will have the left-hand side, will also have your right-hand side. Okay? So in your left-hand side, where you are going to have d squared y over dx squared, make that to be r squared. Okay? Then we are going to have dy over dx, make that to be r. Okay? Then the coefficient of y, you are going to make it to be p. Okay? It's different from what we have been doing in the first order. Then we are going to have this auxiliary equation, which is r squared plus r plus q equal to 0. Then we are going to solve for your r. After you have solved for your r, you are going to find that you have three things. Okay? One, your roots, which are your value of r, can be equal. If they are equal, this is found on page 7 as well. If they are equal, we are going to make your complementary function to be this one, which is y equal to e to the exponent rx, a plus xb. Okay? If the roots are not equal, then your complementary function, which is going to be this one, it will be y equal to a e to the exponent r1 x plus b. Okay, there's not supposed to be a here, it's supposed to be a b. So just please make sure that, let me highlight that out so that you can see. So yes. Okay, so it will be b e to the exponent r2 x. That will be your complementary function. Then there will be instances where you are calculating your r. You find that you are having complex numbers, okay, like we are having here. Then your complementary function is going to be y equal to e to the exponent ax into a cos bx plus b sine bx. Okay, that's your left-hand side. Then we are going to go to the right-hand side. On the right-hand side, all you need to do is to look what you are given. Okay, you are going to be given either a constant value, which we say f at x equal to k. So you are checking on your right-hand side. Am I having a constant value? If you are having a constant value, therefore your particular integral, which we call pi, is going to be y equal to cx to the exponent 0. In the textbook, you will see they will say y equal to c. They will not put that x to the exponent 0, because we know x to the exponent 0 is equal to 1. But I'm putting it so that when you go to your differentiation, it will be easy. Okay? Then we have, if we are given a straight line, your f at x is equal to mx plus k, which is in the form of a straight line, then your particular integral is going to be y equal to cx plus d. Okay? If you are having a quadratic that you are given, which is f at x is equal to ax squared plus bx plus c, your particular integral is going to be y equal to cx squared plus d plus e. You can see I'm not using the value of a, I'm not using the value of b, because we have used that in our complementary function. So we can't use it also in the particular integral. I'm using other letters. Then there is this one, if we are given f at x, which is equal to e to the exponent kx, now there are two solutions. It's either you are going to use this one or you are going to use this one. In your textbook, they put it this one, okay? So this is the first one that you will check. But you will only use this if the value of k here is not the same as any value of r where we are calculating here. If it happens that the value of k and the value of r are equal, then you use this one, which is y equal to x ce to the exponent kx. Okay? If you have a trigonometry, whether you are having sine kx, you are going to say y equal to c sine kx plus d cos x. If you are having f at x, which is cos kx, you will use the same one. It will not change. Okay? Once you have identified your particular integral, the next step is that you need to differentiate your particular integrals. Okay? You'll find the first derivative of your particular integral. You will also find the second derivative of your particular integral. Now you'll be ready to find your general solution for this one. In order to find the general solution, we have done all these calculations that we have been doing. You will substitute on the original equation the value of y, which you have identified as your pi. Okay? You will substitute the derivative of that pi which you have done here. You will substitute the second derivative of the same pi that you have done. This will be mostly on your left-hand side. Okay? Then you keep the right-hand side as it is. Don't change the right-hand side. Thereafter, you calculate the values of your coefficient of pi. Remember, your pi is going to have c, it's going to have d, it's going to have e. Okay? So you are calculating the value of c, you are calculating the value of d, you are calculating the value of e. If it's only have the value of c, that's the one that you are going to calculate. Okay? Especially we saw when we are having a coefficient, a constant value. So you're only calculating the value of c. Okay? Or if we are having the exponent. Okay? Then once you have your values of c, d, and e, you can now generate your general solution. Your general solution is going to be equal to y equal to your complementary function. You will take it as it is with the values of a, the value of b. You are not substituting them. Plus your particular integral. But also in the particular integral, you are substituting the value of c, the value of d, the value of e. Okay? When you are calculating your particular solution now, you are going to be given the value of y. You are going to be given the value of x as coordinate. So you substitute that into your general equation. Then you are going to find the first equation. Okay? Then you are going to also go and take that same general solution. You are going to differentiate it. Now you can see we are doing a lot of differentiation. Once you have differentiated it, you are given the value of dy over dx, it's the one that you are going to substitute, and you are also given the value of x that you need to substitute. You substitute these values, you will get the second equation. From the second equation, you can now solve for a and solve for b. Once you have solved for a and b, you take your general solution, you substitute the value of b, the value of a, obviously the value of c and d and e you have substituted before, then you are going to get what we call your particular solution. Let us see one example of this. Okay? So your one example that I'm going to give you, it's taken from the past papers as well. So we are having d squared y over dx squared minus 6dy over dx plus 5y, which is equal to 5e to the exponent 5x. You are given the x coordinate, you are given the y coordinate, you are given the dy over dx coordinate, which goes with its own x value, because we are going to be calculating a particular solution, not a general solution. Okay? Let us see how does this work. We have said that you will make d squared y over dx squared to be r squared. So we are having r squared here. Minus, we are having a 6. We said dy over dx is going to be r, so we are going to put r. We said the coefficient of y is going to be q. So this is the value of q now, which is 5. You equate it to 0. Okay? We said then you need to solve for your r values, which are your roots. Obviously, N2, you are doing this factorizing. So in this instance, you'll have r minus 5, and also you will have r minus 1, which is equal to 0. Therefore, your r1 is going to equal to 5. Your r2 is going to equal to 1. Then you check. Your r values in this instance, they are not equal. Okay? So if they are not equal, if we go back, remember we said here, if your r values are not equal, therefore, your y value for the complementary function is going to be y equal to aer1x plus b e to the exponent r2x. So we need to write that now because that is our complementary function. So it is y equal to a e to the exponent r1x plus b e to the exponent r2x. But we do have the value of r1 and r2. Let's substitute it. So y equal to a e to the exponent 5x plus b e to the exponent 1x, so x. So we call this our complementary function. Okay? Now, once we have calculated your complementary function, you look at the right-hand side. So our right-hand side in this particular instance, remember, we had 5e to the exponent 5x. So since we are having this, our y is going to equal to, okay, so we check here, so we are having ye, so we are looking at this one. It's either we are going to use this, which is y equal to ce to the exponent kx, or this one, which is y equal to x ce to the exponent kx. But now our k is 5. One of the r is 5, which is r1. So therefore, we are going to say that our particular integral function is going to be equal to now cx e to the exponent 5x. Okay? So we are taking that one because this, we are taking it as straight away from here. Okay? So this is what we are having. So we call this our particular integral. Okay? So we have this, we want to differentiate. So we want to find dy over dx. Obviously, we are using product rule. So let's differentiate this x first. So therefore, we are going to be left with c e to the exponent 5x. Then we differentiate this part here using the product rule. Then we are going to get 5c x e to the exponent 5x. Then we differentiate the second derivative of this. Okay? So if we differentiate this now, we are going to get 5c e to the exponent 5x. Then we differentiate with this x. So we are going to get another 5c e to the exponent 5x. Now we go and differentiate this because remember we are using a product rule here. Okay? So we are now going to get 25cx e to the exponent 5x. Okay? You have done your second derivative, first derivative. Now it's saying we need to substitute on the original equation. So we are going to have 10c e to the exponent 5x. Then we are going to have plus the 25c x e to the exponent 5x. Minus, we had a 6 here. Okay? If you go back to your formula, to your equation that you are given, we have minus 6. So we're putting minus 6 back as it is. Okay? Then we have 6 here. Then we have dy over dx. But dy over dx, we can substitute it with c e to the exponent 5x plus 5c x e to the exponent 5x. Then we close that bracket. Okay? Plus the value of y. So we need to add the value of y. The value of y is cx e to the exponent 5x, which is equal to, the right-hand side we're keeping it as it is, so which is 5e to the exponent 5x. Now we need to multiply this bracket out. So we are going to take now, we are having the 10c e to the exponent 5x. Then we are going to have plus the 25cx e to the exponent 5x. Then we multiply inside here, we are going to have minus 6c e to the exponent 5x. We multiply the last one, which is going to be negative. Okay? So when we multiply the next one, it's going to be negative 30 cx e to the exponent 5x. So we left the value of 5 here. So we put it now. So 5cx e to the exponent 5x, which is equal to 5e to the exponent 5x. Now we add the like terms. We have this one, which is 10 c e to the exponent 5x. We have this one as well, which is minus 6 e to the exponent 5x. So this is going to give us 4ce to the exponent 5x. Then we have 25cxe to the exponent 5x. Then we have 30cx e to the exponent 5x. Then we have this one. So if we add this 25 and 5, we are going to get 30, which is going to be subtracted here. So now that one is gone. So we are left with equal to 5e to the exponent 5x. We divide with 4e to the exponent 5x. Divide on this side with 4e to the exponent 5x. Therefore, our c value is going to equal to 5 divided by 4. So this is our c value. So if we were looking for a general solution, we will have stopped here. But now we are looking for a general solution. But let us write our generals first before we write our particular. Okay? We said our general solution is y equal to cf plus pi. Okay? So our cf, since they were not equal, we said y is equal to a e to the exponent 5x plus b e to the exponent x. Now we are putting the last one, which is going to be equal to plus, which is our pi. Our pi has c. Now we're no longer writing the c, but we are putting 5 over 4 instead of a c. Then we have e to the exponent 5x. Okay? This is our general solution, if we wanted the general solution. Now they want us to calculate the particular solution. So that's what they want. Okay? Want your particular solution. So you are going to first substitute the value of x and y here, which those values of x and y, you can find they are given there. Y is equal to 3, x is equal to 0. So you substitute now. Y is equal to 3, so we are going to put 3, and then x is equal to 0. If we put x here equal to 0, we are going to have 5 times 0, which is 0. E to the exponent 0, we are going to be left with a. Okay? The same here, if we put x as 0 here, we are going to be left with b. The last one, if we put 0 here, all of this is going to be equal to 0. So this, we call it our equation number 1. Okay? Equation number 2, it says differentiate your general solution. So if you want, you differentiating your general solution, which is dy over dx, so it's going to be 5a e to the exponent 5x. Then it's going to be b e to the exponent x. Then this one obviously is a product rule. So we differentiate that x first. So it's 5 over 4 e to the exponent of 5x. Then we differentiate the e to the exponent 5x. Therefore, we'll have 25 x e to the exponent 5x, all divided by 4. Okay, on the next session, we are going to substitute, because we have already calculated this value, but you can be substituting on your own. Now, the value of dy over dx, which is 0, and the value of x, which is 0. We are going to find the equation, which then we are going to use those two equations to find the value of a and b, which we are going to come back and substitute on our general equation here. But we will do that on the second session. Thank you. Again, I'm found under Umgungundlovu TVET College. You can email me. Please put Mathematics N6 as your header so that I will know it's your Maths N6 guys. Thank you very much. At kingswelly@gmail.com.